All right, that is going back in the car, Mac valve, and I have the information in order to pin everything. This is the prototype of the Delfino project that's going to be running my Corvette. What I have done on here is I have all the pins inside that I've connected to it. Basically, it's going to control the Mac valve, the O2 or the O2 sensor, the Bosch 4.9 for the wideband controller has already been wired and tested, so I know that works. The only thing I did add was the actual Arduino itself and everything else in there. Again, this is a prototype. It's all on a prototype board, but we'll plug in the Mac valve. I need to find a place to put it. I'm thinking maybe like somewhere down here. I got the mount, so maybe like right here, and then run my reference lines to the wastegates for that. But I need to depin a couple of items on here, as well as change like the O2s, because I'm going from the P01 that had their own ground, like dedicated ground, to the controlled low from the P59. I have the wiring info here, so it's got your low signal, high signal, but the PCM, and I need to verify this because I have actually had a P01 that with a 6.0 that kind of did something similar to this, but I guess all these P59s do this too, is the green pin on 72 and 74, they are a switched ground, so when the PCM isn't connected to anything, if you try to test the continuity to see if it's grounded, you won't get anything. I did try that and it wasn't grounded. So my guess is this must internally set a ground trigger to control the wideband sensor. I'm going to do a little bit of verification on that to double check that, but that's how I'm going to wire that up because right now I don't have any O2 sensors that are working. It worked on the P01 but does not work here. And if you had ones that were obviously controlled, you'd be fine. These aren't even case grounded. These are actually have their own to the bus bar that's in here. But I ripped one of the injector wires, so I do need to figure that out. I think I'm just going to cut that off, and I believe I have up there, I have like some of those EV6 to the Delphi connections, so I'm just going to, I don't need them, and plus I only have like 7, so they're worthless. I'm just going to cut one, get rid of this plastic, and then just redo that, so that'll also be on there, and I can get that so we actually have number 7 on here. I accidentally did that because I was checking my injectors and I realized that one of them was mislabeled. These are decaps, and it was off by like 3%. And not only that, but it was actually, if you ever talk to anybody, you want your highest flowing injector on bank 7, because that one typically gets the hottest. So obviously a little bit more fuel can cool it down, especially E85, it's really nice. But I switched it out to where this was the highest flowing one at like 76.5 pounds. These are all like 75, 76 pound. They're within good enough for me. So yeah, I got to cut that and fix that. And then get the O2s working so I can at least have the commanded AFR correct and then have this read. And then I need to get a harness over to the LCD screen that I have there, and that will display everything that I already have coded in Arduino, AFR, boost pressure, and then I want to test it. I don't know if I'm going to be able to bring it up to 2 pounds. I highly doubt it, even with a quick rev. The coolant system isn't done on this, so I really don't want to run this longer than I have to. To me, I get a little sketchy after about 15-20 seconds of running this, especially if you're revving it out to where I just don't like it unless it's got coolant in it. But I'll try to see if I can bring it up at least a little bit on idle, just to smash the gas a little bit and see if I can read that. Obviously, I'm not going to be able to hear the Mac valve over the engine, but if I can get it up there, I can at least read. This is only going to turn on it'll only turn on if you have the stage set between 1 and 3, and if it sees more than 2 psi of positive pressure. So that's the way it's supposed to work. I got to get 2 ignition wires on that to run that. One is to the wideband, which I think is already wired in. So yeah, so I already have that wired in, so I only have to add one more because I believe I have the, is there a 5 amp? Yeah. Yeah, so I already have a 5 amp in here, and I'm gonna add a 3 amp for the Arduino, so I'll put it right here for that. So I only have to do one power wire in, and then we can see if it works, and if it does, then we already have a working prototype, and we'll just keep going on from there. So this next portion I'm going to put in here is going over the code. I actually had a video on this earlier, but I didn't like it because it had a lot of feedback. So I just went over again, and the audio is actually semi-good. There's no feedback, it's just a little bit of crappy recording noise. But you can skip past that to the very end, and I'll have it marked in the video. And then the next portion will be this testing out and see if it works. So hopefully it does. Let's try it. Okay, so I'm going to go over the programming for this Dolfino project. This is the coding that is for the entire setup that I have going on here as it sits, October 24th, 2021. This will change as time goes on, but this is set up for wideband control, boost control, like stage control, and then reading boost pressure and some other items. So I'm literally going to go down the whole entire setup here. To some it might look small, to some it might look like ridiculous garbage. To me it looks like ridiculous garbage because this isn't what I typically do. I'm not a programmer, I'm not a developer, even though computers are my hobby, or not my hobby, my career. I can't really say they're my hobby anymore, but they are my career. But doing this is definitely not in my scope of work that I typically do on a daily basis. But I do want to go over on the self-taught setup here for piggybacking to the Gen 3 LS stuff that I want for my setup. Eventually this is going to be continue to grow as others, if they want to join on this, but otherwise I'm going to keep going myself. But we're going to go down the list here on what's up. So this is Project Dolfino. It's a multi-stage boost controller using the 35A series Mac valve. The parts here I have listed. So it uses an Arduino Nano as basically the main brain of the whole entire system. It uses a 2.5 bar map sensor. It's an MPX 4250 AP. You don't have to worry about the AP portion, but this is like the run-of-the-mill map sensor that's used for like the Speeduino and the Mega Squirt and all that stuff. It's like an $18 to $20 little 6-pin map sensor, even though it only uses 3 of the pins on it. It's very stable. It works really well. There's a bunch of code for it, so you can use it to do a bunch of other stuff. So I just use it to read boost pressure, aka kind of gauge pressure. It's calibrated to my sea level. That's something I'm going to kind of maybe mention on here as the bottom too, as well as setting up a calibration code for that as well, depending on where you're at, and power on, power off. But anyways, we'll keep going here. It uses a 35A 3-port Mac valve, and then I use the Spartan 2 OEM wideband controller. So this is like a DIY little PCB wideband controller. They have 2 versions of this. They have a I2C, or some people call it I2C. But I don't use the I2C, I use the linear version, but the I2C version talks directly to the Arduino using the I2C protocol. And then the linear output is 0 to 5 volt, which is what I use because I can use it to punch into the EGR pin on the P01 or P59. I use a P59 myself. And that way I can put the math into a VCM scanner to display my AFR, as well as to the gauge itself to Arduino, so I can split that signal, and it works really well. They're both 0.01% within accuracy, so their website says, so I'll take it for what they are. It seems to be spot on because I did a test on it, and the commanded AFR, and then what was actually coming out was within like a third of an AFR. So, or like it was reading like 11.5. The wideband controller is reading like 11.0. So that was like the farthest it was off. Otherwise, it was pretty spot on. So it seems to work. I'll kind of try to fine tune it and see if it's actually legit as time goes on. But from what I've done research on, they're pretty good controllers. So I'm going to stick with that. They're 35 bucks a pop. They work really well, and we'll go from there. So this uses also a dual MOSFET trigger switch. I did a first PCB prototype
That should be here probably in the coming week. And I already built a second prototype that uses a single MOSFET versus a dual MOSFET. Like these dual MOSFETs you can get off Amazon. They're just like your typical PWM trigger switch that can work up to like 60 kilohertz. But I they're just so bulky, so I want to get something smaller. And then these are also good for like 36 volts. It's overkill to run a 12 volt MAC valve, so a single MOSFET itself, and then the circuit that I built in the PCB will work as well. But this is just what's built for it. This will obviously not change. The code for it will stay the same with the PCB that I built, so you don't have to change that. Uses a 10K resistor for pull down on the switch. There's more to this with the PCB I made, but the way it stands and stuff that works, this is just how I have it set. That way the Arduino knows that I click the push button, and then it knows to cycle the stages for the boost controller, and then I had the push button as well for the switch. 12 volt to 5 volt adjustable voltage regulator. This uses like a buck converter to go from 12 volt from the car to 5 volt or 5 volt on the rest of the systems. The Spartan 2 OEM uses 12 volt to come in, so that doesn't run off the voltage regulator, but everything else runs off that voltage regulator. The sensors, Arduino, anything that needs 5 volts will go off that. It works really well. You can adjust it and fine tune it. I have it like within like 5.01 volts, and I can pull a bunch of power down on it and change the power coming into it from like 12 volts even all the way to like 6 volts, and it stays exactly 5 volts. So it works really well. I like it, and I have no issues with it. So that's just what I use. I put a diode between the MAC valve power leads because that prevents flyback. What that is basically when the system powers down and the MAC valve is energized, if everything is off and the MAC valve is energized and has to go off, it might backfeed, which is flyback, and the diode will keep it so that the current does not come back through. It only lets current through one way, and it won't let current through the other way. So it's just blah, out. So that's just like going on the parts used, and then this is where we start the, I guess, variable portion of it. Not the setup on it, because that is down, where is it? Right here. But this is just setting up like the pins and stuff. So the LED pin is 13. The Arduino Unos and the Nanos, they have a built-in LED on the board, and they are powered. If you if you set the pin 13 to be on and off, the LED will come on and off. So instead of adding an LED, you can just use the onboard one if you set it to pin 3, which is what I did. That way I set it to when the button is clicked. That way I know when the button is clicked that it's actually working and it's not dead or not wired correctly. And if I see the light flash, I know it's reading the button. And if it's something else isn't working, then I have to look into it. So that's what I have there. It's nice to have. That way you know your button's hooked up correctly when you actually click it. And then the button pin is on pin 11. That just knows when the button is clicked that it needs to change the stage. The button state. So these right here, this is kind of to set everything back to 0 with the button state. So when the Arduino starts, it knows it needs to start at 0. It always checks for the last state. That way, if you go past 3, which is the max stage I have, it knows to go back to 0, and it always checks for the count. I can't tell you exactly why everything is. See, state of the button, last state of the button, and the button press counter. So it always equals 0 and then plus 1. I'll show you when we get down here, but basically this is just there so that every single time the calibration is always set to 0 as start. And then here are the duty cycle variables. There's 4 here. 3 of them are actual stages. 4 is just, the 0 is just off. And then 1, 2, and 3 are your stages. Again, we'll go over this when we get to the setup down low, but duty cycles 1, 2, and 3 are separate stages, and those are based on the integer set for the output for pulse width modulation, and those are just knowing that these are to be set for variables on that. So map sensor is set to A2, analog pin 2 on the Arduino. The solenoid pin to run the MOSFET trigger to the MAC valve to run it from pulse width modulation is set to digital pin 3 If you put D3 here, it works just fine, but if you put 3, it knows to go to digital. And then the wideband equals A1, analog pin 1. That is the input to read the wideband sensor. So, or wideband controller, sorry. And then here's the actual setup of everything. So, so all of these variables have been set for the most part. And then you have your pin modes through here. This knows that it's basically telling the Arduino what each pin is going to do, whether it's going to be an input or an output. So the LED pin that we set is going to be an output. That's going to trigger the LED pin when the button's pressed. The button pin is going to be an input. That way when you actually hit the button, it knows to read it and then do whatever you want when the button's pressed. The map is an input. It reads it. Wideband input reads it. So this is an output because this is for the MAC valve, and I cannot tell you how this came to be right here. I have no idea why it is a thing, what it means. I basically just went online to figure out what I can set the frequency for to run the MAC valve trigger, and the lowest I can figure out to do it is 30 hertz, and this is the code to set the frequency for pulse width modulation on that pin that you select to be 30.64 hertz. Now, the MAC valve runs well at 15 to 35 hertz. The thing is, once you get too high, the resolution window is shortened. So what I mean by that is, let's say you were able to set this at like 15 to 20 hertz. You would be able to run like 10% to 90% duty cycle, and the MAC valve would function within that. Anything lower, it's fully off. Anything higher, it's fully on. That means it's just clicked open. The higher frequency you get, the less resolution you have, the less duty cycle you have. So at 30 hertz, like 20% to 75 is about max, depending on how you set it up. But that's about what I've been able to find, is 20% to 75% is basically the window you have to work with. So down here you can see I have it set to 30 to 60. That's a safe window because it just functions. I can set it to 30, anywhere from 30% to 60%. I can just play with it. It works. If I go over 75%, it just stays open. And if I go below 20, it just stays closed and doesn't really open up. It sounds like it, but it's not really doing anything. So this is the lowest I can get it to go. That's the code for it. And then the pin mode to run it is obviously an output. So this is the beginning of the LCD output on this. I forgot to mention up here. So I use a 1602 LCD that uses an I2C module. Basically, it's a nice module to have on these things because it's only 4 pin. If you just get the normal 1602 LCD, these are like 9 pins to run the whole thing, and it's really annoying. If you get like the I2C versions, they have also 2004s. That 1602 is 16 pixels across, or 16 integers across and 2 vertical. And then if you get the 2004, it's 20 across, 4 vertical. And then you can start, like, as it goes on, you start getting to like 128 by 64, and you start actually having like LCD outputs, which is eventually I'd like to do for my gauges. But for this setup, it's easy just to get these little cheap LCD screens that are extremely visible and they work well. And this is the setup of it. So it's saying to begin the LCD output, and then this is just for the serial output, so I can read it from the computer. It runs 9600 baud, and then, excuse me, this is the duty cycle variable that I was talking about. So since it's doing an output from the analog, or from, not the analog, what are we talking about here? Where is it coming out here? Digital pin 3. The integer is 0 to 255, and based on the integer from 0 to 255 is your 0 to 100% duty cycle. So you can basically whip out a calculator and figure out the math on that. 0 to 255 equals 2, 0 to 100. Obviously 255 is 100, 0, 0, so you can do the math on that. So I set it up. I wanted 30, 45, and 60, and then 0 is wastegate. Obviously, that's just completely off. And then that's just wastegate. Obviously, the MAC valve isn't running. So 80 is 30%, 115 is 45%, and 153 is 60%. Easy enough, simple math. So this is the entire loop that it's going to continue to keep running. There's a lot here. The bottom portion is not super important, but I'm going to try to swing through this really quick um, to what is going on here. So first thing, button state. It reads it on a digital pin. I already set the button pin up for the variable. So it knows just to read it, figure out what's going on. If it sees a button press, it does some stuff depending on what you have written down here. So the next thing, it's going to do the math for the map sensor read. So it's going to read the raw value from 0 to 5 volts, whatever the map sensor is sending to it. And then that runs the raw voltage input for it for the integer is 0 to 1023. Again, you can use the math is from 0 to 5 volts, whatever it equals 0 to 1023. And then this is like the basic math for the MPX 4550. Don't ask me where I found this. There's a bunch of forums online that I found it, and what I had to do was this is like the basic math right here. It floats this portion right here. Excuse me. And then it also minuses by 14.7. It would minus 14.7 if you are at sea level. I'm not at sea level. I'm 1,000 feet above it. So what I have to do is I have to take the sea level number here. I have to minus what I get for absolute pressure, which is 14.2, which gives me a 0.5 psi difference. Now, if I was lower, this would be higher. So I'd get negative number. But since I'm lower, or since I'm higher, the absolute pressure is lower. That's as you get higher up in the sky, the absolute pressure goes down. So I take this number and I add it to the normal 14.7. That way it calibrates my gauge pressure because it's a map sensor which does absolute pressure. It'll give me a gauge pressure at 0. Obviously, if I were to drive the car to say like Colorado, this is going to change. And then here I explain how I want to do a calibration check. The easiest way to do it would be do it on power off and on, and it could read the absolute pressure and then make the change depending on what it's supposed to see at sea level. But what would also be nice is like every 5 minutes it could do a calibration check, and if it sees that especially let's say you're like cruising down the highway, it would see that there was a pressure change. It's supposed to be like say a vacuum pull of like 10, and it realizes that it went from 10 to 10 and a half within 5 minutes. It's going to calibrate it unless it sees, this would be almost like PID stuff, which would be a lot harder to set this up. That's why I might not do it myself. I might have someone smarter than me try to figure this out. But the easiest way to do this would be power on, power off. That way it calibrates it without the engine running, and it says, hey, it's supposed to be 14.7. This is what it is. Minus it, boom, done, and then there you have it. So that way, if you were to put this whole system on a switch, you could just be like pop, pop, power off, power on, calibrate, and turn your engine over and start. But this is the math for it. It's a 2.5 bar map sensor. It works for my 2-bar setup. That way I can actually read what's going on. It can do what I need to. So this here, it sees the button state. If it's high, it lets the LED light on the Arduino know to click on. If it's low, it knows to just shut up and turn off and just stay off. So here it says check if the push button is pressed. If it is, then the button state is high. If the button state equals high, then the last state is 0. That's where it starts. So it starts at like null. I need to kind of adjust this code so when you start the car, it actually just doesn't display number. And then when you click the button, it knows it's 0, but when you click the button, it goes to 1. And then from anywhere else there, it goes back to 0 if you go past 3. This right here, excuse me, if the count is less than, or if count is less than 3, it goes back to 0. It pluses 1. Otherwise, it goes back to 0 right here. Basically, if I were to change this to 4, it would go up to 4 and then back to 0, and it always go up by 1. If I change this to 2, it would go obviously 0, 2, 4, 0, 2, 4. So we're not going to do that. We're just going to set it here. If you wanted to be an absolute psycho, you would do this, and you would have every duty cycle run through from 0 to 255, and then you can be an absolute maniac, but we're not going to do that. So, and then here it's just the printout to the LCD screen. Sets the cursor to stage 4 on the top section, and then it just prints the count. That's a variable actually. So it looks at the count and then sees whenever the button is triggered, and then it sets the state to 1. So it'd be 1. So when it's at 0, null, then it goes 1, 2, 3, 0, 1, 2, 3, 0, and it just keeps doing that. So, and then here the button state is low. It just knows the last state is always 0. I don't know why this is here. I don't know why I need this. If I were to remove this, I'd be curious to see if it would actually still work. But it just works now, so I don't want to touch it. And then this is where the real magic happens, honestly. This is kind of the most important part of it to control the Mac valve. So when I originally wrote this, it was just this portion right here. And what it would do is like, hey, if it's set to 0, the count 0, it runs the duty cycle of 0%. If it's set to 1, it runs the output. Don't look at the map output on this because this was added later. It just said count equals 1, equals 2, equals 3. So it would just set the duty cycle based on it. And then one random night in the at 12 o'clock at midnight, I was like, wait a minute, if this car's idling, I'm gonna have a vacuum leak if this thing's running. So I need a way to set it to where it will not run. It'll still know what stage it's at, but it can't run until it sees like positive pressure. So I had to write the and map output greater than 2, which is 2 psi, and I had to write this in here too, that if it's not 2 psi, it just stays to duty cycle 0. That way the map sensor, or the Mac valve does not run at all until it sees at least 2 pounds of pressure in the manifold, positive pressure, I should say. That way it won't run until it sees 2 psi, and then it goes, okay, what stage are we set at? And then it looks at the stage, and then that's your duty cycle. So obviously you can make this a lot higher resolution. For me, I just like a simple 3-stage setup. And then all this stuff is very unimportant, maybe other than the math here, but this is just more LCD stuff. It just sets the word boost PSI right at the beginning, 0, 0, so that's top right at the beginning. And then this is printing out the map output information. So this would basically be outputting the raw information, or the raw voltage. So it reads the raw voltage from 0 to 5 volts. It divides that by 1023. That's the integer for the analog read. And then it does the math for it. And then this number right here is for gas AFR. This would change if it was for like diesel or E85, which is something I'd like to add to, depending on, I would like to have if you were to run a flex fuel, if you were to add an alcohol sensor to it, it would see what the percentage is, and then it can make the change to this number based on the alcohol percentage, and that would give you your AFR. I would need to talk to other people that are a lot smarter than me on if that's a smart idea, but in my brain, it's like, hey, whatever, say it's like 50% alcohol, it can do the math and say, okay, we're going to change this number based on the alcohol percentage, and then give you your correct AFR on that. And this just knows to print wideband AFR information on the LCD screen. And then all this stuff too is just basic setups for map output. This is just literally the word level. This is literally the word AFR, and then where to set an LCD screen. This right here is kind of interesting because, like, if you were to have say you have an AFR of like 9.9 to 1, it's going to display 9.9, and then when it goes to 10, it's going to have a 0 at the end. And if it goes back to 9.9, that 0 is actually going to stay there. So you have to add this in here to basically flush that number out. And like here, it says sets the number back to 0 if additional number gets on the screen. So that's the setup on it. I probably did a really shit job of explaining that, and I'm sorry, but I just kind of wanted to go over the basics of this. All this stuff is on my GitHub, which is in the description that you can click on and go over it. So I'm going to continue to keep adding to this as time goes on. I'd like to get it. I already have on that GitHub. I already added the second revision of the PCB on there, and on there too actually has the circuit that I have yet to test fully, but it's supposed to read the serial line, the J1850 VPW line, raw data, and I should be able to take that information and try to pull the RPM signal, the mile per hour signal, and the gear selection, or the PCM commanded gear out of that. That way I can start to do boost by speed, RPM, and gear. And if I start to get more into the PID stuff, I can actually do boost by map. That way you can basically say, hey, I want 16 pounds of boost. You set it to 16 pounds, and the MAC valve will control it using PID and pulse width modulation to say, hey, we're going to keep you at 16 pounds, and it just does a ramp in, out, and stuff like that. So this is just to get everything set up. This is the big first revision of this, or the big first setup of this. But as time goes on, I'm going to continue to keep adding to it. This is going to work for me, but as I get more bored as time goes on, I'll continue to keep adding it. But other than that, that's all I have. If you guys have any questions, you can comment. Otherwise, you guys have a good day. Talk to you later. Bye.
ECU's in. This little hodgepodge reference line is just obviously temporary. I need to get some hose, but it's on the reference line inside. This is to the Arduino inside. This is to the Spartan 02 wide sensor. This is a 5 amp. I need to get a 3 amp for that. I believe it's downstairs. I'm just too lazy to grab it, so I put a 5 amp in there. And then it's hooked up to the back of the manifold. The injector is fixed. It works. The MAC valve is not hooked up. It'll hook up the button, but it's not obviously hooked up here. And it's not like we're going to be able to hear it anyways. It should just it's right there, not like I'm going to pick up anything. But set this off to the side. Got a nice mess right there. I need to clean up. Why won't this come off? Really? Is this what we're going to do now? Look at this. This is awesome. All right, so let's just jam that back in there and I'm gonna make a cover for this. It's just not seen because I need to start zip tying all this excess up. So here is the little button. I need to get one to go replace one of those switches, like a push button. So I just have a little soldery boy on there right now to click, click, click. Battery's hooked up. So let's turn ignition on and see what we blow. This would be sweet. That's good. So our SDA and SCL cable are backwards. Easy fix. 1 second. Blow air into it. Next stage. Works. And it's all in there.